Good morning all. Hope y'all's having a good day. Now here's a Lenze drive. It is type EVS9326-ES. And we don't know what the problem is. Come into the shop, malfunction unknown. And that's the way most of them come into the shop. So the first thing I like to do is make sure that the line side is not shorted. Here's L1, L2, and L3. Here's the DC bus. You have access to the DC bus right here. It's plus UG and minus UG. Now on the other side is the motor output, the IGBTs to the output, and they're labeled U, V, and W. Let me get my meter in here where y'all can see it. And we are going to test for short circuits on the line side, the three-phase bridge, and the motor side. So what you want to do, can y'all see that meter? What you want to do is take your black lead, put it on plus UG. This is the plus DC bus. Take your red lead and put it on L1. And we got a good diode drop of 0.522 volt. Now move your red lead to L2. We have another good diode drop, 0.522. Now L3 with the red lead, good diode drop, 0.518 volt. Leave your black lead on plus UG and put your red lead on bus ground, minus UG. We got a good diode drop of 0.795. Now we're going to go, leave your black lead on plus UG. We're going to go over to the motor side. Here's U to plus bus. There's a diode drop of 0.439. That's good. Here's V. Diode drop of 0.439. That's good. And here's W. Diode drop of 0.439. That's good. Now, remove your black lead from plus UG. Place your red lead on minus UG. And there's L1 to bus ground. We have a diode drop of 0.487 volt. Black lead to L2, diode drop of 0.476. Black lead to L3, diode drop of 0.479. That's good. Now take your black lead over to U. There's a diode drop, 0.436 volt. That's good. V with the black lead, diode drop of 0.437. That's good. And lastly, black lead on W, red lead on bus ground, diode drop of 0.435. No short circuits. No short circuits. That's good. We're going to hook up the line voltage now. The line voltage, according to the data plate here, input three-phase 400/480 volt. I'm going to put 380 into this drive. That's close to 400. This should power up with 380. We'll look at these LEDs and see if they light up. If they don't light up, we have a problem. If they do light up, we'll try to run this drive. Right, there's the line connected to the drive, L1, L2, and L3. Let's plug ourselves into the wall, and then we'll power this drive up and see what she does. There, we're plugged into the wall. That's turned on. Let me go over here and turn the transformer on. No bang, that's good. But do we have lights? No, we don't. Also, I didn't hear the pre-charge relay energize. This drive did not power up. We're going to have to go in and determine what the problem is. Let me turn the power off. There, we're off on the wall. Transformer's turned off. Let's unplug ourselves from the wall. We don't want to get ourselves lit up on this nice Sunday day. Okay, I'll disconnect the line and we'll disassemble that drive. Once you get this cover screw out right here, you'll notice that the cover doesn't want to come up. Well, it's because on this end right here there's a little hook. There might be two, I can't remember. But I have to reach up in there with a flat bladed screwdriver and unhook it. You can see right there's the hook. And that hooks around this metal piece. And once you unhook that, the cover comes right off. Then these three screws come out. And this one screw right here. Usually there's two of these screws, but this one is missing. We'll have to replace that screw before we send it back after we complete the repair. Now there's three screws right here, and I'll use this gray one right here, I think it is, to remove those three really tiny screws. They hold this metal plate to the CPU board. Now, this should come right off. I'll set the cover and the metal plate off to the side. We're going to remove the CPU board. Now we've got to be careful. Well, look at this. This is interesting. Now there's a flexible ribbon cable that goes from the power board to this side of the board, and this flexible ribbon cable is ripped, but somebody has got in here and did some repair. Isn't that amazing? Can you all see that? How close to that? So they replaced the flexible ribbon that joined the top power board to the bottom power board with wire. That's pretty ingenious. Now, when I remove the CPU board from the power board, there's a stake connector down here. And I'll grab these gray connectors right here. And I'll put the palm of my hand on top of these capacitors to hold the power board down. But you got to watch out because there's pre-charge resistors right here. And you can crack those. And if you crack those, you have to replace them. There's no repair on those things. And the only way to replace them is if you have a broken drive back in the North 40 that you can cannibalize them off of. So put your palm here, be careful, and then just rock this back and forth until the stake connector, that's this connector right here, disconnects from the power board. Well, that's not a good sign. These are all new caps. These are not the caps that Lenze likes to put on their drives. So somebody has already, yeah, you can see this is not factory solder right here. Somebody has already tried to recap this board. Down here in this power supply section, these green caps, these are all new also. So somebody has been into this drive. It's going to make it very difficult to repair. Reason being, if the recap that they did didn't fix it, that means that the problem is much, much deeper than just bad electrolytic capacitors. Well, here we go. Let's see what we find. Oh man. Now what I'm going to do is I'm going to power up this isolated power supply. And when I do, this red LED should blink if that section powers up. To power up that section, we apply plus 24 volts DC to pins 6 top or 6 bottom and ground on 5 top or 5 bottom from an external plus 24 volt DC power supply on this X50 connector. Over here is pin 1, 2, 3, 4, 5 will attach the external plus 24 volt ground, and pin 6 the plus 24 volts DC. And if all goes well, we'll see that LED blinking. That will rule out whether we have a problem here in this power supply or the power supply on the power board. Make sure we have 24 volts. There we go, 24.09 volts DC on the purple wire, and ground of that power supply on the brown wire. purple wire. Let's get untangled here first. Put the purple wire on 6 top. There's 1, 2, 3, 4, 5, 6. Try not to bend these because you want these wires straight when you go to attach it back to the power board. Otherwise these pins will get bent out of shape. There's 1, 2, 3, 4, 5, the ground. Here we go. Look at that. We have a blinking red LED. Can y'all see that? Try to hold these wires right here. That means that that power supply, that isolated power supply on the CPU board is good. Don't let that 24 jump onto that 5. We will have a dead CPU board if that 24 volts gets over there on that 5 volt circuit. Alright, let's get a little bit closer to that blinking LED. Another thing that could cause this drive not to power up is a short circuit on the control board. Now, the 5 volts and logic ground for these ICs is derived from the switch mode power supply on the power board. And the 5 volts comes in, let me show you my diagram again. The 5 volts from that switch mode power supply on the power board comes up to the control board on pin 13 bottom. And the logic ground is on 10 top, 16 bottom, or 21 bottom. So what I'm going to do is I'm going to put my red lead on 10 top and my black lead on 13 bottom, and we should get a good diode drop on that control board. So here we go. Here's the top side. There's 2 rows, top and bottom. Pin 1 over here. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's our ground. 11, 12, 13 bottom is where the 5 volts comes in, and we have a good diode drop of 0.427 volt. So there's no short circuit on that 5 volt logic. So this board is not causing that switch mode power supply on the power board to shut down. We can call this board good. And we can concentrate on that power board over there. I don't see no explosion damage on the heatsink assembly. Here's the three-phase bridge. Here's the IGBT. They look to be intact. Here's current sense. Here's the firing channels for the gates of the IGBT. They look good with my eyeballs anyways. Let's move this out of the way. There's little clips right here that wrap around the board, so you have to separate this plastic from the board. Bend that out a little bit. That'll come up. Bend that one out a little bit. Let's go over to the other side. Unclip this side. Oh, Lordy. Do you see what I see? All right, folks, I think we're done. Look at that. Oh, what a mess. Let me get this plastic insulator off of the drive. Come on. This side over there don't want to come out. Oh, what am I hung up on? There we go. Oh, Lordy, 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 look at that. Now, if that ain't an explosion, I don't know what is. I'm surprised it didn't go bang on us. Look at that. What a mess. And even down here on the other side, look at this. Here's a trace that is just completely opened up. Oh, Lordy, we ain't fixing that. Okay, we're going home. We'll see you next time. Oh, 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 dear Lord. We'll have to give that one a good funeral. It gave up the ghost. All right, all. Hope you're having a better day than I am. We'll see you next time.